In 3.2, we're going to start to look at how to generalize the graphing like we did in 3.1 if we have equations that have exponents higher than 2. So these are not quadratic equations any longer. So the first thing is that polynomial functions, polynomial is when we have a bunch of pieces added or subtracted together, that's what we're dealing with here, are graphs that are smooth, and smooth means that there's no sharp corners, so like an absolute value function is not a polynomial because there's a corner there. And continuous. Continuous means that you could trace that graph without picking up your pencil. So the question here is does this represent a polynomial function? So the first thing in A is that there's no sharp corners, it's smooth. And the second thing is that I could trace that without picking up my pencil, so it's continuous. So A is yes. In B, there's no sharp corners either, but if I try to trace it, I have to pick up my pencil to get to the second piece. That means that there's a break in the graph, and that makes it not a polynomial. End behavior is what the graph does on the far left and the far right. The leading coefficient and the degree tell you this information. So the degree is the highest exponent. And the leading coefficient is the number in front of that piece that's got the highest exponent. If the degree or the highest exponent is an even number, so you have numbers like exponents like 2 or 4 or 6, then that means the ends are going to go the same direction. If the number in front of that leading coefficient is positive, then both ends are going to go up. And if the number in front is negative, they're both going to go down. If your degree is odd, so that means the highest exponent is like 3, 5, 7, the ends are going to go different directions. So if the leading coefficient is positive, the right end is going to go up and the left end is going to go down. This is like your x cubed equation. That's that graph you should know. But if that number in front is negative, then it flips it around, and so the left hand will go up and the right hand will go down. So let's practice this. So now we want to talk about the end behavior. So the highest exponent is 4. That means our degree is 4, and that's an even number. Okay, the number in front of that degree of 4 is 1. So our leading coefficient is 1, which is positive. So this tells me the ends are going to go the same. This tells us that it's either going to be like this or that it's going to be like this. And the fact that my leading coefficient is positive tells me that they're both going to go up. So my final answer is that it goes up on left and up on right. So let's look at this one. So first of all, let's look at the degree. So we have to be a little bit careful here. The highest exponent we see is x to the third, but there's also an x here and there's also an x here, and those are all multiplied together. And if we took an x to the third and we multiplied it by 2 more x's, we would get x to the fifth. So my degree is 5, which is odd. And that odd tells me the ends are going to do something different. So the ends are either going to go like this, or the ends are going to go like that. So then I have to look at my leading coefficient. And the leading coefficient is this number that's in front. The leading coefficient here is 2, which is positive. And that positive leading coefficient tells me that the right end is going to go up. So my final answer is left goes down, right goes up. I always think about the leading coefficient positive always tells me the right end is up. And the degree tells me whether the left end matches or is opposite. If the leading coefficient's negative, the right end goes down. And the leading coefficient, or the degree, tells me whether the left end matches or goes opposite. Okay, so here there's the highest exponent is 3, and there's nothing multiplied by it. So my degree is 3, which is odd. Okay, and that tells me that they're going to go opposite directions. It's either going to go like that or like that. And then my leading coefficient is in front of that. It's -2, which tells me it's negative. And the negative tells me that the right end has to go down. So I have this one. Left goes up, right goes down. Zeros of the polynomial are the same as x-intercepts. So to find any x-intercept, remember we set y equal to 0. And in this section, we'll solve by factoring. In the next section, we'll look at another way of solving. So the first thing you should always do when you're factoring is look for a greatest common factor. Once you have a greatest common factor, then you need to continue factoring. You do by grouping if you have 4 terms, difference of squares if you have 2 terms, or the trinomial. Remember, difference of squares is when you have 2 things that are squared, and it factors to be a plus b, a minus b. Then you set each factor equal to 0 and solve for f. The degree tells you the number of solutions. So if that highest exponent is 3, there should be 3 answers. If that highest exponent is 5 or degree 5, there should be 5 answers. So here we can see that the degree is equal to 3, so there should be 3 solutions or 3 x-intercepts. So the first thing we do is we set it equal to 0. So we get 0 equals x cubed plus 2x squared minus 4x minus 8. And a lot of times people don't like having that 0 on the left hand. That's fine. You can move it to the right hand. You can make it equal to 0 that way. This has got 4 terms, so we're going to factor it by grouping. The greatest common factor in this first 2 terms is x squared, so I'll factor that out. X squared times x gives me this x cubed. Keep that plus. X squared times 2 gives me this 2x squared. Over here, the greatest common factor is 4, but they also both have a negative, so I'm going to do -4. And then negative 4 times x is what gives me that negative 4x. And negative 4 times a positive 2 is what's going to give me that negative 8. Still equal to 0. When we factor by grouping, this that's in parentheses should match this that's in parentheses. We write that once. And then we write what's left in front together in another set of parentheses. This is a difference of squares, so it can still be factored. So we'd have x plus 2. And this factors. This would be x in both. This one would tell us it's 2 in both. 1 plus 1 minus equals 0. So now we have 3 pieces. We need to set each piece equal to 0. So I'd take this first one, and I'd have x plus 2 equals 0. Subtract 2 from both sides. It gives me x equals negative 2. So there's one answer. And then I take this, and it's x plus 2 equal to 0. And that's exactly what we had here, so that gives me the same answer. We wouldn't write it more than one time. We would just write it once, but it's important to know that it was really there as an answer 2 different times. And then finally, we'd have x minus 2 equals 0. Add 2 to both sides. And we have x equals 2. Now remember we said we had 3 solutions. Well, there they are. X minus 2 again, and x equals 2. But when we write it, we would only write the x minus 2 one time. Okay, so let's look at this one. This says my highest exponent is 4, so it's degree 4, which tells me that there are 4 solutions. So we set it equal to 0 first. X to the 4th minus 4x squared equals 0. There's a greatest common factor here of x squared. So I take out the x squared. X squared times x squared is what would give me x to the 4th. And x squared times negative 4 is what would give me this minus 4x squared. Now this is a difference of squares, so we can split it up. X at the beginning of both. Oops. 2 at the end of both. 1 plus, 1 minus. And this x here can be split apart also because it's x squared. So it would be x times x plus 2 times x minus 2. It's degree 4, 4 pieces, 4 solutions. So here's a piece, here's a piece, here's a piece, here's a piece. So we set each of those equal to 0. We'd have x equals 0, x equals 0, x plus 2 equals 0, and x minus 2 equals 0. This one's solved. This one's solved. Here I do minus 2 on both sides. So x equals negative 2. And here I do plus 2 on both sides. So x equals positive 2. So I have 4 answers. If you're writing them as a solution set, you wouldn't write that 0 more than once. You would just write it once. Multiplicity describes how many times a specific 0 is repeated. Even multiplicity, so if an answer is repeated 2 times or repeated 4 times or repeated 6 times, it means the graph touches the x-axis at that spot, but it doesn't cross it. So if the x-intercept was right here, it might come down and touch it and go back up, or it might come up and touch it and go back down. If it has an odd multiplicity, so it's repeated once or 3 times or 5 times, it means the graph crosses the x-axis at that spot. So if the x-intercept was right here, it means it would cross like that, or if the x-intercept was here, it would cross like that. Either it goes up through it or down through it. So here's an example. We've got this problem. Let me write it down here. We want to say whether the graph touches or crosses at each zero, what the multiplicity is, and then how many times it crosses. So we need to remember a couple things here. This exponent of 2 really means that that parenthesis is there 2 times. And this 3 really means that that piece is really there 3 times. And if we're finding zeros, it means that we're making it equal 0. So we wouldn't have y there, we'd have 0 there. And we'd set each piece equal to 0. So we'd have -4 equals 0, x plus 1/2 equals 0, x plus 1/2 equals 0, x minus 5 equals 0, x minus 5 equals 0, and x minus 5 equals 0. So first of all, -4 can't equal 0, so we throw it out. Okay, that gives us these 2 that are the same, so let's just solve it once. It gives us x equals -1/2. Well, how many times is that repeated? Well, that answer would be here and here. So it's repeated twice. So it's a multiplicity of 2 because the answer would be there 2 times. Okay? So here's the 0. Here's the multiplicity. Because that multiplicity is even, that tells us that the graph is going to touch at that spot. It's not going to cross it, it's just going to touch it. So now let's look at the next piece. Here we've got that same thing written 3 times. We'll just solve it once. So we x is equal to 5. So that's our other 0. It was there 3 times, so it has a multiplicity of 3. That's odd, because 3 is odd. Here it was even because 2 is even. And that means that the graph is going to cross at that x-intercept. Okay, if the multiplicity is even, it touches. If the multiplicity is odd, it crosses. So the direction said find the zeros, give the multiplicity of each, and state whether the graph touches or crosses. It says touches or turns around. That's a mistake. It should be touches or crosses.